We already took a look at a couple of applications of exponential equations, and I chose to take a look at some of the problems involving interest. You will see some other applications in the homework, and I will just remind you that for applications other than interest, the equation would be given. So you may or may not be familiar with the formula for exponential decay. It will be given if you need it. Same thing with any log equations. The equations would be given. So I've just chosen an even numbered problem from the book to work through together. So a company spends X $100 on advertising. Now I want to just pause one moment here because it says X $100. That's telling me that the units for X are not dollars, they are $100. So that if X is 5, that means we spent $500. Okay. Very often in applications, you'll see something like this, where you modify the units of things, and it just helps us to avoid having to plug in and work with really big numbers. If you're spending lots of money, let's measure money in hundreds of dollars rather than dollars. Okay. All right. So we're going to spend X $100 on an advertising campaign. The amount of money in sales, so after the ad campaign we sell some stuff, and the sales, S of X, that's given in $1,000. Different units for X and S of X. So I'm just going to make a note here. X is in $100 and S of X is in $1,000 so that I don't forget that. So if I get that my sales was 5, that doesn't mean $5, and it doesn't mean $500. It means $5,000. Okay, so, and this is the amount in sales for the 4-month period after the campaign can be modeled by this equation. S of X, the sales, is 5 plus 7 times the natural log of X plus 1. Okay, so then they're saying if the sales total was $19,100, how much was spent on advertising? And we're supposed to round to the nearest dollar. Okay, so if this was what was spent in sales, let's figure out what my value of S is. I'm going to plug that in here and then we'll solve for X. But I need to be careful because I'm not plugging in 19,100 because whatever number I plug in, that's how many $1,000 I spend. So whatever I write for S, I multiply that by 1,000 and that tells me the actual dollar amount. Which means this is $19,100. That's a little more than $19,000. That's going to be 19.1. How many thousands is that? I would just divide by 1,000, or equivalently move my decimal point 3 places. All right, so the equation that we are solving then is 19.1 equals 5 plus 7 natural log of X plus 1. So now I've dealt with the units for S. I'm going to have to remember once I solve for X that that's telling me how many $100 I have. Okay, that's my argument. X plus 1 has to be bigger than 0. X has to be bigger than -1. Now here, that restriction is actually kind of common sense. I am not going to be spending a negative amount on advertising. The amount I'm spending on advertising is going to be a positive amount. So the common sense constraints in this case actually are stronger than the mathematical constraint that I have right here. But I do need to write that down. If this had been an X minus 1, I'd have that X had to be bigger than 1. Okay, so the common sense would say X had to be positive, but the mathematical constraint would say it actually had to be bigger than 1. Okay, so let's see. I need to isolate my log. I can see not every term in this equation is a log, so I'm going to want to get the log by itself equals a number. So let's subtract over our 5. So 14.1 is equal to 7 natural log of X plus 1. I'd really like to completely isolate the log, so let's divide over by that 7. I could, if I wanted to, move that 7 up and make it an exponent, but then I'm dealing with X plus 1 to the 7th. I'd prefer not to. Okay, it's going to be a lot easier if I just divide by the 7. Okay, so the natural log of x plus 1 is going to equal 14.1 over 7. Now, that would not be acceptable as a final answer for most problems, but when you're solving exponential and log equations and you're getting things ready to plug into a calculator, I'm okay with that. Okay. All right, so now, it's great. I can actually solve. I'm just going to rewrite this in exponential form. So we'll have a base, an exponent, and a result. The exponent I need when e is my base to get x plus 1 is this lovely exponent, 14.1 over 7. Now, that's not quite as nice as some of the things we've seen before, where we had something like 3 cubed and we could just do that mentally. That's okay. I still want to be solving for x, so I'm just going to subtract over the 1. So e to the 14.1 divided by 7 minus 1 is equal to x. Okay. I can tell that is bigger than negative 1. I know that because this is bigger than 0. So when I subtract 1 from it, I'm going to get something that's bigger than 1. So that's a legitimate answer. On an exam or a quiz, you would just leave your answer in this form. And as I said, in solving these equations, that's the one time when I'm okay with you not simplifying something like that that's a combination of a fraction and a decimal, because realistically, what you'd be doing if you were solving a real-world problem is then using some technology. So let's go ahead and use our calculator, which I might very well ask you to do on a take-home exam or quiz. So we're raising e to this power. Now, I'm going to need to enter that in parentheses, because if I were to enter e to the 14.1 divided by 7, it would take e to the 14.1 and then divide that by 7. I want it to do this division first. So it's e raised to the, let's see, I don't use my calculator very often. Okay, to the parentheses, 14.1 divided by 7, close parentheses, minus 1. Oh, I got a syntax error. Oh, okay. Let's try that again. E raised to the parentheses, 14.1 divided by 7, close parentheses, minus 1 equals. Okay, so I get x is approximately 6.4953 blah, 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 blah. Okay. Now, we were asked to round to the nearest dollar, but that's not $6.50. I need to remember my units. That was hundreds of dollars. Okay? So x is how many hundreds of dollars. That means the number of dollars, which is not x, that would be 100 times x, is the number of dollars that I would have. That would be approximately 649.5 blah, blah, blah. If I'm rounding to the nearest dollar, I would round that up to $650. So a lot of details to be very careful of there. So I think this was a good problem to work on. The actual equation wasn't super bad, but we did have some messy stuff to enter into the calculator. We had to be very careful about our units. And that's something that you'll see very often in applications.